Welcome back, mathletes. Today we are going to take a look at the use and misuse of graphical representation. The first part of our video is going to focus on what type of graph best fits the data and shows what you're trying to represent with your data. The second part of this will take a look at some of the ways that graphs can be misleading. Many entities that want to present you with data will try to present the data in a way that makes them look better or makes you lean toward one conclusion or another, regardless of what the data actually says. So that'll be what we look at in the second part of this. First, let's take a look at the average points scored per game for the top 10 scores for the NBA 2022 to 2023 season. These were the average points scored per game for different players. We want to take a look at each one of these different representations and talk about the strengths and the weaknesses. First off, we have a pie chart. Looking at the pie chart, there's not one section of the pie chart that stands out as being the top high scorer or the lowest high scorer. So that might be something to think about when we are talking about using a pie chart. So it doesn't easily show highest and lowest scorers. All of the pieces look relatively the same size. Generally, if we're going to use a pie chart, we want one section to be obviously larger than the others, and that's just not something we see here. The other thing that I notice with this pie chart is that it doesn't show the actual points they scored. It shows percentages, but percentages of what? And really, if you're looking at data about the top scorers for the NBA, you want to know how many points they scored per game. So it looks like the pie chart might not be the best representation for our situation. If we look at a line graph, typically a line graph is used for changes over time. Well, we could look at changes over here on the y-axis, but on the x-axis, we have names. We don't have a list of times right there. The other thing we have to take a look at is, let's say we need a point right there, because since these 2 points get connected with a line, that means there should be data right there. Well, if we zoom in, this looks like it would be approximately 28.2 points in a game. You can, and I don't follow basketball that closely, but I am fairly certain that a player cannot score 28.2 points in a game. So our line graph is showing continuous data. Rather than only discrete data. When our points scored in a game are definitely discrete data. Now let's take a look at our bar graph. On our bar graph, we can see a highest and a lowest. We have a maximum score right there with Mr. Luka, and a low scorer right there with Kyrie Irving. We can also tell that these two guys appear to tie for the lowest score in a game. We can see, it appears anyway, that Luka and Joel also might tie for that high scoring points. So it's possible. It also is showing discrete data. If you had it labeled, we can absolutely stop those bars at positions that represent our data. It's not like we have space in between our points like we did on the line graph that represented fractions. Bar graphs also get used to show how many, or the frequency, I guess I should say, of things happening in a certain category. Well, if we consider the names of our players as categories, our frequencies show up on the left axis. So that one looks like it could be okay. We'll check out the histogram. If I go look at the histogram, this histogram, number one, I notice it's not labeled. I don't know what I'm looking at down here on the independent axis. Because of the numbers involved, it appears, anyway, that we are dealing with points scored. And it looks like this first bar is for players who scored between 27 and 29 points. And then from 29 to 31 points, and 31 to 33, and 33 to 35. One thing I notice is that it very clearly shows which category most of the players fall into. Most of our players fell into this 31 to 33 points per game category. So that is useful information. but it doesn't show the points per game like the bar graph did. So in this particular case, I would say that the bar graph probably has the best representation of individual points scored per game than the rest of them. We'll go look at one that's a little bit different. We have an amusement park planner who wants to better understand the distribution, in case that's a new word or an unfamiliar word. We're looking at how spread out. The wait times are. So at the park one day, he asks 15 random people about the length of time they had to wait, and we're doing this in minutes. What type of graph provides the best visual representation of this data? A circle graph, a box and whisker plot, or a bar graph? So again, we are looking at how spread out the wait times are. So let's take a look at our graph. First of all, we have our bar graph. That's a little bit blurry. This is person A, and this is B, C, D, and so on. Now, I do like that this graph shows me very clearly the longest wait time was 12 minutes, and the lowest wait time was 0 minutes. So that's helpful. It doesn't show me really clearly, though, how spread out those values are. So let's see what other graphs might tell us. Taking a look at the circle graph, it looks like I do have one section that stands out as being the largest. That means 20% of the people surveyed spent 0 minutes waiting. So that's good. It looks like we have 3 sections that are roughly the same size. And then all of the other ones are pretty close in size too. It does make it easy to see where the shortest wait time was. It doesn't make it so easy to tell where the longest wait time was. And it doesn't tell me how spread out my data is. The last one you have is a box and whisker plot. And with a box and whisker plot, I can very easily find the average wait time. I can find the minimum wait time. I can find the maximum wait time. If 0 is the minimum and 12 was the maximum, that also tells me over what numbers my data was spread out over. So this looks like the box and whisker plot is the best representation since we're looking for the distribution of data. Now let's take a look at what to look for in a quality graph. Every graph needs these things for sure in order to accurately represent data. So make sure your graph is labeled. Your graph has to be labeled sufficiently. That means you have your axes labeled. What does the x-axis represent? What does the y-axis represent? Make sure you see units of measurement. What are we measuring in? Are we measuring in inches, feet, people, dollars? Also, make sure that your categories are labeled. So that on your bar graph or your pie chart, you know exactly which section represents which category. The second thing you always want to look for is the scale. We talked about scales on pictographs. Make sure that you know one sunshine equals 2 days at the beach. Make sure that on a graph, if your y values are counting by 50s, that it's labeled. And it's labeled correctly. Make sure that one doesn't go by 50s and the next one goes by hundreds. So be careful there. The third one. Are you seeing the full picture of the data? Or just a small portion? So are the presenters letting you see all of the data, or did they just pick out a chunk that makes them look good? So we're going to go take a look at some graphs. This first one says it's the average salary for an adjunct professor at 4 colleges. So we do have a title. Tells us what we're looking at. It labels the colleges. So that works in our favor. Here's my question, though. For Eastern College, I don't know what these values are. There is no label. For the vertical axis. I don't know what they're counting by. I don't know if for sure looking at salary, or maybe they accidentally graphed vacation days. We don't know what that graph represents. So there's the problems there. Let's say there were values there. Let's say they told us this was the salary, and you were looking for a job, and you wanted to choose which one of these colleges you wanted to work for. Well, ideally, Central College looks like it has the largest salary out of all of these. But maybe it's 60 miles away from your house. So you go and look at Eastern College. Maybe it's only 15 minutes from your house, but its salary looks like it's way lower. Well, if I give this a scale, maybe this is 30,000 and 31,000 and 32,000 and 33,000. Now, with a scale on there, we're going from almost $32,000 to $33,000. That's not a big enough difference that it would affect most people's decisions. But without that label, it could possibly be that this is 30,000 and 40,000 and 50,000 and 60,000, and all of a sudden that salary difference is much more significant. So that's one of the things that makes looking for labels super important. Now let's take a look at attendance for a game, some type of sporting event. I'm guessing with the St. Paul Strikers, could be a baseball team, could be a bowling team, who knows? But anyway, when we look at the graph, we have years across the bottom, and we have, I would assume, attendance, but we don't really know what these are. That's not very clear. If we go look at the Minneapolis Wildcats, we don't really know what these are. We can assume fairly safely that these are years. And when we go look at the graphs just at the surface level, it looks like the St. Paul Strikers have more people attending their games. But when I go and compare them, if we assume that the vertical axis is people attending the game, when I look at how the graph is scaled, this looks like it's just above 16,000 people. Maybe this is 16,500 people. When I go look at the graph for the Strikers, this might be 14,500, maybe 700. So when you look at them, they don't look that far off. But really, the Minneapolis Wildcats had more people attending than the St. Paul Strikers because of the way the graph was scaled. So look out for that. The other thing is the Minneapolis Wildcats start counting at 0. The Strikers start at 10,000. So that makes a big difference too. So make sure you look at those. The last one we're going to take a look at is a pie chart. In this pie chart, we have two different representations. We have a regular pie chart, plain vanilla, run-of-the-mill pie chart. We can easily tell that we have two much larger sections than the others. It's very easy to tell that the green one is smaller than the other ones. When they tilt that pie chart and make it 3D, all of a sudden, data starts to look a little bit distorted. all of a sudden, it looks like the green section for item C is bigger than the blue section from item A, when in reality, the blue one is 11% and the green one is 5%. Also, it starts to look like item D is larger than item B. But in reality, they're the same size. So be careful when you look at pie graphs. Make sure you make sure you see percentages. Without the percentages labeling the graph, it's hard to tell what the graph is actually telling you. Make sure that you realize a tilted graph distorts the images. So hopefully now you have a better idea of what to look for in a graph. Sort of critical thinking questions to ask yourself when you are presented with data to hopefully have you make good decisions about whether or not to trust what you're being presented with.